Right, after a lot of designing, a lot of messing about with the model, I obviously been testing out these segment sections, and I doubled them up. Actually, I'll show you in my drawing, because when I put the doubled up versions, what I did was I had to take them out of here. Actually, I had to take these individual ones and put them side by side, and it turns out that when you introduce a gap between them, and I worked that out by using this bit of cardboard stuff. I actually just put it in between the segments to get the right gap. And so when I put the two of these side by side with a gap, and I move them across the transitional magnetic field between this pole and this pole, we get a very even transition. Think of it a bit like a bar graph display, because there's the steel, the nanocrystalline material is in one side, and as it crosses over the plane, the transitional plane, it actually reverses its bias, its magnetic field, and the other ones maintain the other ones. So we get a nice even transition between the two poles, so we get a lot less cogging. So I'm actually printing out at the moment my new segments, which are going to have, which I'll show you the drawing. I've made a printout so you can see a lot easier the arrangement, and all being well, we're going to have a lot less cogging. But as I said previously, it all adds up. So I came up with this. This is my new rotor arrangement with the nanocrystalline wafers. So as the rotor moves, and it's all equally spaced as well, so the spacing's still right. Because what I did was, when I made these slots, when I doubled the slots, I actually measured half the extra distance this way and half the extra distance that way to maintain that spacing between them, so it would be equalized. So that's the new arrangement, and when I turn it over, we see how it intersects with the magnets. And as you can see, it's still well within the flux field. So everything, this magnet here will say it's south. Everything between here, this probably better if I use my. Everything between this side here and this side here is one pole. So it's south basically from here to here, and so it encapsulates our segments. But once the segments start to move on the rotor, and it's moving, it crosses over to this other half, it starts to transition. So these segments on here will become the other pole, and then this will become the other pole. Then we'll have a half and half situation where this is, say, north and this is south as it's crossing over this plane over here. So it creates this even transition. It's kind of progressive, because as it moves further, we end up with all of this segment here being north, this being north, this being north, and this one on this end just being south, but it's starting to lose its south field as well. And then eventually, once it crosses over to the plane, it becomes these on this side, which is the other pole. So we have a much less coggy problem, which is what I was trying to achieve, because it's, as you know, the cogging issue wasn't a problem until I started to get a much stronger magnetic coupling, which is when I moved these magnets closer to the segments. It started to become a big problem where I couldn't even turn the damn thing with my fingers. So this will rectify that problem, and I can pack two nanocrystalline pieces in there, or I can put 3 in, so I can double them up. There's room to get extra ones in, because I left a little bit of slack around these. I don't know if you can see, but there's a bit of a gap between all the way around to allow this thing to swell up. Obviously, if it's too slack, I can wrap some tape around the outside to pack it to make it tight, but I shouldn't need to worry about that. But once I start packing material in, this is so thin, I mean, this is about 1mm. It's about 0.5 mm gap between there and there. So it's so thin that it bends. So that's what I wanted. So I could pack extra material in, and this would expand a bit, and it would allow me to pack a bit more material in there to add more nanocrystalline sheets in. But so the idea about these little bits here that come into the middle is to intersect the magnetic field to create more repulsion against the magnets, which are obviously behind here. Now obviously it wasn't easy for me to, because this, we're talking about 0.5 mm. These are like 0.5 mm. I mean, it's ridiculous. I mean, it's not practical to be able to get the nanocrystalline curved into these points, but I left a bit of space so that I could, in theory, stick some thin pins down there to create that couple in there if I need to do, but I don't think I'll need to do, because I've done some tests just with the straight material all the way down without going into these sections, and it works really well, as in very little cogging. So, but yeah, I put them in just in case I needed to short out a bit of create a bit of repulsion on this side. But anyway, that's where we are at the moment, and I'm printing out the actual these things. I'm actually printing one out right now, which is on the printer bed, plus the four inserts, the pink things. So I'm printing out four of them as well. I've actually got I've got another 2 down there which I've done, which are in acetone paper right now. So yeah, that's where we're at the moment. Just thought I'd let you know and show you what we're doing. Bye for now.